A very beautiful evening, professional colleagues. It's a pleasure being with you at a time like this, and thanks for the opportunity to share my thoughts on the subject that you've already talked about. This evening, we are going to be looking at safety critical drawings as instruments for preventing incidents. If you look at the incident, the flow chart for what causes incidents, you typically look at three things that potentially we have to focus on, looking at it from the perspective of people, looking at it from the perspective of equipment, and looking at it from the perspective of process. And for us to be able to eliminate any incident, we have to see what do we do to address the people aspect, what do we do to address the equipment aspect, and what do we do to address the process aspect. So the discussion of this evening has a big connection with the people aspect in terms of incident causation and prevention, and then the process aspect also. And then, as we will discuss, you also see that equipment comes in, even though not directly. The drawings actually represent what equipment we have, which in the course of what we do, maintaining and making decisions, can also play a big role in terms of incident causation. Let's come back to the basics. At every workplace that we have, some of the constants are that people change. People can change through being transferred from one location to another. People can change through resignation. We can have issues where people have worked up to a particular time that they need to retire. And then in some exceptional cases, you can also have instances where people lose their jobs through either termination, suspension. Maybe they've done one thing or the other, or breach company procedures, and disciplinary action has taken. In summary, people change from their work site. The other aspect is also, that's also key, is that for safe operations of any facility, transfer of the right information to the right person is key. And this is necessary for routine operations. It's necessary when you are embarking on new projects and you have to make decisions, as in, what do we do about this? It is key when you are modifying facilities. Maybe in the course of your operations, you want to implement certain changes to bring about improved efficiency or effectiveness of the facility and similar things. It is key passing of the right information. It's also key when you are mentoring new employees, even in terms of continuous development of old employees. But if you want to look at the different industries that exist, you see that there have been repeated instances of incidents occurring as a result of people either relying on wrong information, or the right information not being available, or the information that is available being insufficient for people to be able to work safely. And one other constant and key is that we cannot rely on the human memory for effective storage of safety critical information. There are a lot of decisions that needs to be made. I mean, if you go into a typical process facility, you see a lot of things that happen there, a lot of equipment, a lot of interfaces, a lot of interconnections, and we can rely on human head to be able to remember all this. And even if you were to remember, how will a human head be able to effectively transfer this information to the next human being? And remember that saying, that the faintest pencil is better than the best brain. So our discussion this evening is going to look at some of the key drawings in our industry, which for us to safely operate our facilities, we need to rely on them. And then we'll take a little bit of highlight of each of them, and then ultimately come back to talk about what's our role as safety engineers, as professionals. What is expected of us in ensuring that safety critical drawings are available for people to use, so that we as professionals can also be key contributors in the drive towards the elimination of incidents in the various workplaces. Why do we need drawings? Some call it diagrams, drawings. I mean, why do we need key information on our facility? Why do we bother ourselves talking about safety critical drawings? Think about simplified ways of providing information for people to actually understand what is happening on the facility. I mean, in every day-to-day operations of the facility, people need to make decisions. So you need to have a reference that people can refer to as part of what they use to drive safety, what they utilize to drive facility integrity, and what they utilize to ensure that even the essence of the business is achieved and that the continuity of the business is maintained. Safety critical drawings also are essential tools in terms of transfer of information, like I've said before, transfer of knowledge, mentorship of new people, orienting people that you bring into the organizations, training people at the work site to be able to actually understand what is happening and what is expected of them. And generally, in terms of manpower development, it's key. And then when something goes wrong on our different facilities, it is a key thing that we need to know why. Why is it happening? And safety critical drawings are valuable tools in terms of being able to do troubleshooting, in terms of being able to do incident investigation. I mean, picture a typical root cause failure analysis. I mean, you can hardly do this without having to look at things like drawings. It is also key in terms of eliminating potential errors on our facilities. I mean, errors people make, mistakes people make that typically can result in incidents. I mean, some of these can be in the aspects of, I mean, when you are doing process hazard analysis of a facility, pick your typical hazard setting. You need to have drawings that you can make reference to check from one node from one node to another, or you want to divide the facility into different systems and analyze, trying to see what potentially can cause problems and what do we do to make sure that those do not cause problems. Safety critical drawings are key and necessary. And then in a typical facility, people make a lot of decisions. Decisions as in, let's go in these directions, let's make this modification, let's adjust the facility this way, let's isolate at this point, or if we do this, this is what it can impact on. You need drawings, you need the right set of information to be able to make these decisions. Else, you may be making the wrong decision, and anytime you make a wrong decision, there's that potential that people may be exposed. Day-to-day operations require documentations, require drawings that you can make reference to. I mean, on a typical facility, people do isolations for maintenance, people do temporary defeats and a lot of other things. You need drawings to be able to ensure that the decisions you are making on a day-to-day aspect of the facility are the right ones. And then think about managing critical devices. I've talked about isolations. Think about you planning for maintenance. It is key that you have the right drawings that can enable you make the right decisions in terms of what do you want to defeat, or what area of the facility do you need to isolate. And if I isolate this, what potentially may be impacted? And then in terms of maintenance planning, is this something that you need to throw into the bucket of shutdown based on maintenance complexity? Or is this something that can be done while the facility is on? And even in terms of the design and maintainability, you will need to consider this. I mean, in terms of being able to sectionalize the facility for the purpose of maintenance and operation. And drawings are key in doing all this. Picture how difficult it can be every time you want to take a decision on a facility, you have to walk the lines. How can you walk through a facility of several kilometers of lines? How can you walk through a facility with that loops are not even on the surface for you to see? How can you walk through electrical line drawings? I mean, so Even if it was possible, for instance, if you want to look at P&IDs, the piping and instrumentation drawings that may reasonably be on the surface, picture the amount of man hours that you have to utilize to be able to do that. And for every decision you have to take, picture you having to do that. And so looking at this, you see that drawings, safety critical drawings, some call it integrity critical drawings, are essential tools for a typical process facility or any typical facility that we operate in. And as safety engineers, it is key as we get into any facility or any facility we're interfacing with to also check. This can be a good reference point in terms of us, whether newly employed or already operating there, being able to connect with what exactly is happening. How can I actually understand this facility and what's going on? And some of those drawings that can actually be of use. Typical example can be the piping and instrumentation drawings. Some typically call it P&IDs. Some can be safety equipment arrangement and evacuation layout. Another one can be the electrical area classification diagrams. Think about single line drawings. Talk about cause and effects matrix. Talk about safety analysis, functional evaluation chart. Some call it in short shape chart. Talk about instrument loop diagrams. Talk about fire protection and suppression drawings or layout. Talk about underground electrical drawings. What about system electrical and hydraulic schematics? And then for the purpose of this drawing, think about logic diagrams. I mean, you just get a facility, it's already constructed, you get into the facility. How do you get to know where to even start? I mean, it is almost obvious that a typical facility will outlive many people, or new people are brought in, or people resign or so. So how does that new guy that gets into the facility, how do I, as a safety engineer, ensure that what is happening at this location, people understand that this is what is here, this is what is there, and if I have to make contribution, I can make the right contribution. If I need to understand the facility, I can understand the facility. If safety-related decisions are to be made, which many decisions on a typical process facility will have directly and indirectly implications with safety. How do we know which source to go to? And how do we ensure that we are applying the sources rightly? Let's start with a typical piping and instrumentation drawings. You just get into a facility. This is a typical tool that can help you as a new person or somebody that's actually been on that facility to understand the flow of pipings, process equipment, and how they are connected to each other. This is a drawing that shows you, can go as much as showing you the instrumentation devices that exist on that facility, the control devices, and in a simple language, I would say you can use this drawing to see the overall engineering processes that exist on that facility. I mean, like I talked about before, that it can be challenging sometimes. Every time you want to understand what is happening, you have to walk the line. That is physically tracing the lines every time. But having a piping and instrumentation diagram can be a simple reference point that can show you, oh, this flow moves from here to here. These are the control devices that exist. And if I have to make a decision, take for instance a typical hazard sessions, you want to maybe divide your process into nodes, then you can clearly with the drawing know where do I sectionalize my facility in terms of analysis, and then you know where to focus on before moving to the next. So that's a typical drawing diagram that one, as a safety engineer, can utilize to help him understand what is happening on a typical process facility. Another drawing that can actually be very useful to a safety engineer is electrical area classification diagrams. If I want to put it this way, if you remember the author of The Animal Farm who said all animals are equal, but some animals are more equal than others. In my own way, I will also say all areas on a typical facility are equal, but some areas of the facility are more equal than others. That is in terms of electrical area classification, where you think about a typical facility divided into classes, divided into divisions. And so this drawing tells you which area is what area if I want to put it that way. And it will be that this diagram that will tell you what area has particular type of hazards. That is in terms of class. It will give you in terms of flammability. It will give in terms of combustible dust. What area do I have flammable fluid? What area do I have combustible dust? And that is when you carry the drawing, you can see typically the classes, you can see the divisions of that area. And then, so what this helps you is in terms of the electrical equipment you want to install in a typical area, you have to be sure that that electrical equipment matches with the area classification of that area. If not, you may potentially be installing an equipment that may be a safety hazard within the area that the equipment is installed. And this drawing can also help even in terms of when you are doing process hazard assessment, trying to also look at what equipment are installed in this area. It can be possible that through this drawing, you can identify equipment that are installed at the wrong places. I mean, picture equipment that's supposed to be an area that requires equipment that are either explosion proof or intrinsically safe. And somebody is just installing an average, maybe an equipment that is suitable for indoor unit and it's installed outside. So with electrical area classification diagrams, as a safety professional, this can be a very good tool in terms of you knowing what type of equipment to order for a particular area. Maybe one equipment malfunctions, or maybe that equipment is obsolete and you need replacement. Then you need to refer to the area classification, electrical area classification diagram to know what type of equipment, what properties, what characteristics, what features of the equipment you need to order to be suitable for that area. Because if you order an equipment that potentially maybe is suitable for an area that is maybe class 1 division 1, and then you go and install it in a class 1 division 2, then indirectly it may not be suitable. Remember, electrical area classification gives us information in terms of the hazard present in a particular area and the probability or length of time that that hazard may exist. That is coming down to the level of classifying that area using the word class or division. Then some other drawing that as a safety professional can be really helpful is what we call the safety equipment arrangement diagram. Some people simply call it safety plan. What does this diagram do? This is actually a quick reference guide to show you the physical location of safety of fire equipment. You go into a process facility. I mean, over the years, things could have changed. New people could have come. Things probably could have moved around. How do you know how originally things were supposed to be? How do you know how that facility was designed in terms of safety equipment, where what was supposed to be? So the safety equipment arrangement diagram is that tool that as a safety professional can help you to know, okay, fire extinguisher was supposed to be here, was supposed to have fire alarm here, was supposed to have 3, 4, 5 maybe first aid box on this facility, and these are the locations they were supposed to be. As also locations I was supposed to have an emergency phone, and to help you know whether those things are there. Apart from helping to check in terms of maybe you are doing facility walkthrough to be sure that things are not missing, or to know if things are missing, what to order for and replace. It is also key in terms of maintaining the facility. I mean, you have a typical maintenance plan for people to maintain fire extinguishers, for instance. How does a guy know where these fire extinguishers are supposed to be? How does he know that I'm supposed to have fire extinguisher, but that fire extinguisher is not there? That document that is supposed to help him is the safety equipment arrangement diagram. If you're supposed to have two, that diagram will tell you you're supposed to have two. An area you're not supposed to have, then you can clearly see. And as a safety professional, this diagram can also help us trying to we want to also look at the facility and see where are we? Are we exposed? That diagram can also help you in terms of even critiquing what was done in the past to know whether you need to modify the facility, maybe add more safety equipment, maybe based on new things that have happened to ensure that consistently the safety of the facility is not compromised. Another type of drawing that a safety professional can actually utilize is the instrument loop drawing. I mean, on the typical facility, like we saw when we were looking at the piping and instrumentation diagram that represented a lot of piping, represent vessels, process equipment, instrumentations, and control devices. The instrument loop drawings is actually that drawing that tells you the flow, the path, the loop that this instrument moves. The P&ID just tells you, okay, at this particular point, I have a particular instrument and similar devices. But if you want details about that instrument, where does this instrument move from? What are the connections? How does it move from the field device to the control room or the termination point? The instrument loop drawing is that tool that you are supposed to use. And so it is key for a process engineer, for safety engineers, and for safety professionals to be familiar with that there is a drawing called instrument loop drawing, and it shows detailed forms, detailed things about a typical process control loop or process control system. And in some instances that you may have maybe an instrument device malfunctioning, maybe something happening on the facility that you don't expect to. This can actually be a very effective tool in terms of troubleshooting to know why did we have that safety or device that malfunction, or maybe out there in the field you see something that is happening that is not supposed to happen. I mean, this type of drawing can actually be that instrument that can help us in terms of trying to check whether something is where it was not supposed to be, or whether something in the field, maybe in a machining cabinet, or probably an end device has malfunctioned. So remember that the instrument loop drawing shows the individual devices, individual field devices with the terminals from wherever they are connected up to the end devices from where you have the control rooms or maybe monitoring stations. And in some instances, this can be several meters. In some instances, it can be kilometers, depending on the expanse of the facility. Picture you having a typical transmitter in the field, and then that transmitter will have to move from the field up to a junction box, sometimes into a machining cabinet, before it actually comes to maybe the distributed control system. So for you to understand that loop, you need the instrument loop drawing. And as safety engineers, this can be a valuable tool in terms of troubleshooting. This can be a valuable tool in terms of understanding what is happening on the facility, and it can be a valuable tool in terms of process assessment, and typically maybe when you are doing something like hazard, that is hazard operability studies. Another tool that can also be very valuable to typical safety engineer, I would say, I mean, for the instrument control loop, you have the instrument loop drawings. But for electrical system, you have the single line electrical drawing. What does this do? I mean, picture a typical facility and the expanse of that facility. A lot of electrical cables may not be on the surface. If you need to trace, if you need to understand the connections from wherever each cable as it moves from the field up to wherever it is supposed to be, then you need a single line electrical drawings. In summary, it is a simplified representation of an electrical system and quite detailed because it takes each line on its own. And with these drawings, it can enable you to have a thorough knowledge of electrical distribution system, how it is laid out, how it is designed on the facilities. It will show you the incoming lines, telling you the voltage of each of these lines, what size of this line, what fuses do we have, are there cutout along the loop, what switches do we have, and finally, do we have tie breakers and similar things. It is a single line electrical drawing that can help you in terms of connecting this. And picture that you have maybe a typical incident on a process facility and there's a need to troubleshoot, there's a need to investigate. Typically, this can be a good drawing that can add a lot of value in terms of trying to know what happened. Another sort of drawing that is, quite directly very relevant to the typical safety engineer is a cause and effects matrix. Like we looked at the P&ID, we saw that it contains instrument devices and control, maybe some control systems. Now, coming to the cause and effect device or cause and effect matrix. This drawing is key because it is that drawing that tells you what each device in the field can do. I have a process, maybe a pressure safety high switch in the field, or I have a temperature sensing device in the field. If the temperature goes high, what will it do? Or if I have low pressure, what will happen? That reference document that can tell you exactly the response of each instrumentation device is the cause and effect matrix. Just like the name tells you, it tells you if this causes this, this will be the potential effect. This drawing is very necessary for the day-to-day operation of the facility. Picture a typical facility, maybe a device malfunctions, and you want to understand what are the potential implications of that device that are malfunctioned. Can I continue to operate the facility? Or what? And in summary, you need to make a decision about, do I need to act now or act later? Or what options do I have? The cause and effect matrix is that reference document. Or maybe you want to maintain a particular device, and by the time you are touching that device, the device may not recognize whether it is a human being that is touching him or touching it, or whether it is a real malfunction. So part of the planning, part of the preparation for that maintenance will be, if I touch this device, what will happen? And it is a cause and effect matrix that will tell you that if you touch this device, it's going to shut a particular pump, or it's going to close a particular valve, or it's going to open a blowdown valve. So this matrix, this drawing, is very key to a safety professional. Is very key to a safety engineer working on a facility. It can also help in terms of, even like we talk about hazard and operability studies, trying to look at, you can critique. Yes, people design this facility that this pressure switch should close this particular valve. During hazard, you can critique. Why do I need to close this valve? Or if this device closes this valve, what typically can happen? If you don't have this information, it can be very challenging. Picture a massive facility with lots of instrumentations installed, and you are just seeing the instrumentation, and you can't tell what can happen if this instrumentation malfunctions, or if these instrumentations maybe triggers. So the cause and effect matrix is a quick reference tool. Like I said, it shows the relationship between the input and the output, telling you that for a particular input, this is what I expect to happen. If I touch this device, or if this device malfunctions or activates, maybe sees a real scenario that it needs to activate, then this is typically what I expect to happen. And in terms of even trying to critique and modify or recommend improvements on the facility, having these metrics can actually be a good tool. For instance, you have something that maybe by assessment, you don't think that the potential risk is that much. But when you look at the output is very, very big. It can be something that you can look at, probably consider whether potentially we need to modify such that this input does not give a particular output. And so, like I said, it is a typical tool that can be used when you are doing root cause analysis, trying to know why did this happen, or there is an incident on the facility and you need to investigate, or process upset or similar things and need to investigate. These metrics can actually be a very good reference tool to you as a safety engineer. Another tool is the one that we call the safety analysis function evaluation chart. Some people typically call it the SAFE chart. In some instances, people interchangeably use it with the cause and effect metrics. In some instances, some places they differentiate it. Where it is differentiated, then see the SAFE chart as a little bit of a less detailed form of the cause and effects chart. While the cause and effects chart gets up to the level of individual devices, the SAFE chart typically can be telling you more like in terms of functions. Picture a typical process facility. I mean that you may have something like a shutdown tree that shares shutdown potentials into different functions. Maybe let's call it levels. Maybe they can say that if they say, okay, shutdown level 1, people can look at it like abandon the facility, maybe almost like the worst case that can happen. Maybe shutdown level 2 can be something that talk about shutdown of maybe something like production process. Shutdown level 2 may be something like shutting down a section of the facility, and different depending on the particular facility you are dealing with. So the SAFE chart can be that tool that gives you in a simplified way what happens to the different levels of shutdown in the facility, different aspects of the facility. For instance, it can take out, oh, if I have a level 0 shutdown that is abandoned, then that level 0 shutdown is going to trigger level 1. Level 1 may be something like total plant shutdown, and it may also trigger something like utility shutdown. If you look at the schematic that is used there as a typical example. And then when you have level 1 can typically trigger level 2. For instance, if you have level 1 in the aspect of total plant shutdown, that may trigger a level 2 shutdown. That may be something like compression shutdown, something like production shutdown, or something like water injection shutdown, depending on the different segments of your facility. And then maybe if you have level 1 shutdown in the utility section, then that may be something that can trigger power generation shutdown, maybe shut down the fuel gas system, or initiate a shutdown of the instrument system. Remember, this is what you have in a typical facility will be case by case basis. And so see the safety analysis function evaluation chart as that one that gives more like in a block form. Typically, oh, if I have this level of shutdown happening, what other level of shutdown can it trigger? And then every one that is higher up can trigger everything down. And then in that context. So while like a cause and effect goes into individual devices, and like I said, in some instances, people use cause and effect chart interchangeably with the SAFE chart. But in instances where it is segregated, then see the SAFE chart as a more simplified form of the cause and effect chart. There another drawing that can be quite relevant to a safety professional or a safety engineer on the facility is the fire protection and suppression drawing. Remember, we already looked at the safety equipment layout drawing, which I said in some instances people call it the safety plan. A difference from the fire protection and suppression drawing is while the other one just tells you the physical location of safety and fire equipment, the fire protection and suppression drawings or layout tells you more like in terms of loop, almost like when we're talking about the instrument loop drawing or the single line electrical drawing. So this one comes down to the level of loop, telling you the loop of each fire protection system or operation. How does it flow? From where to where does it go? And so that in terms of malfunction or in terms of troubleshooting, you can actually know where do I go, where are the termination points, how does this move through, and that can help in terms of seeing or identifying what typically is wrong. In summary, this is a diagrammatic way of showing the installation of different range of fire protection system, and then it also contains crucial details about proper functioning, and then enables you to actually see whether you are meeting the maximum efficiency of what you expect from your fire and fire suppression and protection system. And then at the level of critique, you can even have this drawing without even visiting the facility physically. With this drawing, it can give you good amount of information in terms of decision making, in terms of hazard and operability study, to understand whether what you have is enough and what changes can we make as safety professionals to bring about improvement, to bring about efficiency, to bring about effectiveness of what we have on the facility. The another form of drawings that is also relevant is picture a typical land location where you have process facility on a massive layout of land. While in some instances you can have electrical, can picture you have to make decisions. Maybe they need to be maintenance on typical underground electrical cables. Picture that maybe something has gone wrong and investigation needs to be, troubleshooting needs to be done. Picture where people need to dig the ground. How do you know where these cables are laid so that you can be able to decide, no, dig here or don't dig here? I mean, when you cover the ground generally may look the same. But with underground electrical drawings, it can help a professionals to know where these cables are, from where they move and to where they stop, and then enables you to make decisions, enables you to troubleshoot and make similar decisions. Another type of drawing that is also very helpful in terms of safety is system electrical or hydraulic schematics. I mean, in some facilities, you may have interface between electrical and hydraulic systems, unlike the instrument loop drawing that may just show you the loops, or the single line electrical drawing that shows you the flow of the electrical cables from one point to another. Where you have interface between electrical and hydraulic systems, I mean, there are some instances where you may have electrohydraulic technology that you use electrical signal to activate maybe hydraulic system to close certain valves, open certain valves, or make certain decisions, or place certain equipment for you. So system electrical and hydraulic schematic drawings can actually be that tool that can help you to understand how is this facility designed, what is supposed to operate what, and is it doing what it's supposed to do. So in terms of troubleshooting of facility malfunction, in terms of making decisions concerning facility modifications or changes, in terms of deciding whether what you have is enough, whether it's effective or whether it's efficient, these type of drawings can actually be very useful when you are dealing with electro hydraulic system. Another type of drawings that can also be very valuable and plays key role in terms of maintaining safety on a typical facility is a logic diagram. This typically displays the interconnections. You typically will see more like symbols that are used to represent the interconnection between different loops. And like the name implies, logic. I mean, picture a typical PLC that says, okay, if this happens, initiate this. If this happens, initiate this. I mean, picture like even when we're talking about the safe chart, that we have different functions, and then you have a tree that defines things in terms of logic, as in how things can move from one point to another. So the logic diagram is actually that instrument that can help you to understand the sequence of control on a typical facility. If you have something like a PLC installed, then you may have something like a ladder logic that can show you the different logic from one stage. If this one is activated, this is what is supposed to initiate. If this one and this one work together, this is what is supposed to initiate. And then where you don't have maybe like PLC, you have maybe electrical circuit that you are using to do some logic work, then you may have something like relay logic. The key one is where you have a system that is operating on logic mode, that, oh, if this happens, then initiate this. If it's like this, if this and this happens, result in this. Then you need to have the logic diagram. And like similar to other ones, it can be a very useful tool in terms of investigation, in terms of troubleshooting, in terms of making decisions about what changes needs to be done on the facility and how are things going. In case there are certain logic that you may not agree with, or you don't think it is adding more value anymore, and you may need to make some modifications on the facility. But if you don't have this diagram, it may be challenging even understanding how your facility operates. And so, coming back, why do we spend this amount of time talking about safety critical drawings? What is your role? What is my role as a safety professional? What is expected of me? Think about what is expected of me, what is expected of you in the form of the 3 A's. And the first A talks about availability. The second A is in the context of accessibility. And the last A is in the context of accuracy. What does this mean? As safety professionals, part of ensuring the safety of the facility is to ensure that, since we know that drawings, certain critical drawings are essential in preventing incidents on our facility, they're essential in terms of troubleshooting, they're essential in terms of incident investigation, they're essential in terms of making decisions on the facility that may protect people, protect environment, protect equipment. Then we as safety professionals is to confirm that on each of the facilities that we are working or we are supporting, or that we are posted to or transferred to or providing supervision over or whatever, or dealing with that facility, that the right form of safety critical drawings are available. And that the drawings are not only available, that they cover all applicable processes on that facility, all applicable loops that we may need to deal with on that facility. It is also key for us as safety professionals to ensure that these drawings are not only available, that the drawings are accessible. That is, people that need these drawings to work with, people that need to make decisions using these drawings, have access to these drawings. And this can be, in some instance, having a defined means of storage. It can be having a dedicated location where these drawings are stored. It can be, in some instances, making sure that people that need to have these drawings are aware of where these drawings are stored. And in some instances, if possible, it can also be very beautiful, having electronic means for people to have access to these drawings. That is electronic storage and electronic means for people to have access to these drawings, so that you don't only have the drawings available, but the drawings are accessible. And then it is not only enough to make sure that the drawings are available and accessible. It is also key that the drawings are accurate. It is of no use having drawings that are having the wrong information. Indirectly, people will be making decisions based on wrong information, based on inadequate information. And part of driving accuracy of these safety critical drawings is having a structured means of addressing error. I mean, it is possible that somebody can look at these drawings and identify that, no, something is wrong with this particular point. No, this device is not here, or this device has been removed. It is key that you don't just because somebody has said something is wrong, then we just jump at updating the drawing. It is key that we have a structured means of verifying that if somebody says there is an error on the drawing or there's an update that is required on the drawing, that structured process actually verifies that what the person is saying is correct before we go about updating the drawing. It is also key that drawings have owners. Remember that adage that once people say in the village that a goat that is typically fed by two people normally dies of hunger, because the first owner will think that the second one has given the goat food, while the second one will be thinking the first one had given the goat food. Ultimately, the goat will have no food. So if we leave drawings and say, oh, everybody uses drawings, so it has to be the responsibility of everybody to take care of the drawings. Yes, while that is fine, we need to have a dedicated owner. Somebody that owns the drawings, who knows as part of my work for this particular organization, it is my duty. I'm the owners of these drawings. And we need to have some other person that we typically call the custodians, who he had that responsibility for day-to-day usage of the drawings, ensuring that the drawings are used in the way they are supposed to be used. And then the owner becomes more the ultimate authority in terms of where we have to change drawing. And then part of the process to make sure that the accuracy, integrity of drawings are maintained is having a structured process for periodic verifications or revalidation. I mean, apart from consistently and continuously maintained. And then it is also key to have a structured process to prevent people using unapproved drawings or using drawings that have been maybe considered are no longer useful or have been, how do I call it, superseded. Maybe you have revision 1 of a drawings and that revision has been updated and you have revision 2. You need to have a structured process to ensure that the drawings that are no longer valid, maybe has been updated, the old ones are removed, so that people don't use the wrong versions of the drawing, because by using the wrong versions of the drawings, they will likely make wrong decisions, and wrong decisions potentially can create a scenario where people can be exposed, where the facility can be exposed, and where the environment can be exposed. In summary, as safety professionals, it is incumbent on us to ensure that as part of the drive to ensure that people have the right form of drawings, or that we don't make errors, wrong decisions using the wrong drawings, we need to be sure that the right drawings are available, the right drawings are accessible by the people that need them, and then that we have a structured process to ensure verification of the drawings, to ensure that the accuracy of the drawing is consistently maintained. I want to call it a day there. Thank you for listening, and I'm open to take contributions or questions. Thank you.